All right, so let's continue where we left off. All right, let's continue where we left off. Okay. All right, so this is another scenario. I mean, some other scenarios that we can also look on. We'll see how far we can get. All right. So it's a situation about car sales. All right, so let's say you're purchasing a car and let's make the total price or the final price. I prefer the term final price. All right, so that's what you're paying. So let's make the final price. Let's define the variable like we were talking about yesterday. Let's make the final price. All right, so let's make the final price equal to final price equal to F. All right, final price equal to F. And so we have a 6% charge here on the sale of the car. So I'm gonna just convert that to 0.0. Okay, 0.06, right? So that's what 6% is. Okay. 0.06. All right, and what other information we need to gather? See how I'm planning my problem before I start working on a solution. So you have an original price you have to worry about, you have a sales tax to worry about, you have the other charges, and you have the total price. So they say total price is what I call final price, all right? So that is, I call that the final price. Total price, final price, same thing. All right? So if we have a car here, we want to find out what the final price is going to be, all right? So an equation here for the final price could be simply F is equal to, what's the original price? 9,500, right? You have to, that's what you start with. And then you're adding 0, that's for part A, you're adding 0.06 times that 9,500. All right, my multiplication here using parentheses. All right, plus the added price, which is going to be $120. So my equation just has numbers on the right side, right? So this is an equation. It is a valid equation because these are what you call numerical expressions. These are numbers plus numerical expression here, all right? And so for this here, you're going to have the same thing again. This time you're going to replace this with 14,699. Same idea, just replace that. Same thing here. Now this time is different. Part C, I want to do differently. So part C, you were told that the total price is going to be $22,480. You are not told what the original price is. So we're going to define a variable for the original price, and we're going to call that original price. We're going to call that P. All right, so I'm going to call the original price P. So original price, I'm going to call that P. And so 22,000 is just going to be, 480 is just going to be P plus 0.06 P. That's the taxes that you're paying. And then you're adding the $120. So that would be your equation for part C. We already found out what our equation was for part A. Part B is similar, so I'm omitting that one. And here, I'm borrowing from this. The original price is P. I don't know anything else. So all I have to do is I have to use the variable F for the total price. And so I'm going to have everything on the right here. P plus 0.06 P plus 120. And that would be that situation. Now, part two, what would you do if the sales price was R% and the miscellaneous charge was M? It's the same. It's not really anything different. You just now you can go to variable mode. Everything is a variable now. R% now is gonna be F. For R%, you can write R over 100, or you can write 0. I don't want to use a weird number, so I'm just gonna do something. Percent means out of 100, so I'm just gonna write instead of writing the weird 0.00R, I'm just gonna write R over 100 times P. Right, so R over 100 times P plus 120. Right, so this equation now I have F equals P plus R over 100 times P plus 120. So that's your generic equation. And that's basically it. All right, that's it for that problem. All right. Okay, let's move on. All right. So car prices, awesome. Awesome. So this is just going over what we were talking about. So, all right. So this part of the lesson is just showing you that what we were discussing was true. They use T, I use F. Again, in this case, T and F are the same thing. You can use T, you can use F, same idea. I use F because I was doing this from my head and I wasn't looking ahead on this, right? And then here, you can see here for the final price, we have R over 100, all right? If we know what the original cost is, we can put it in, which is what we have here, all right? And over here, R over 100. So what we did was correct. That's all this is saying, all right? So we did it correctly, okay? And so we can ask questions about the equation. What quantities do we know? We knew the original price some of the times. We definitely knew the taxes at all times. And we knew the miscellaneous cost of $120 at all times. As the equations progressed, we found out more information. Sometimes information was withheld from us. And that's basically the idea. You work with what you have, basically, that's it. All right. Okay. And if you have any questions, you can ask now. All right. So the key takeaway for this lesson is that letters can be used to represent quantities that are constant, right? Letters can be used to represent quantities that are constant. We might, let me put a change here. The author might have had a little problem here. Letters can be used to represent quantities that are variable, should not be constant. If it's a constant, we don't use letters. So it should be variable or not constant. So that's an error. So letters can be used to represent quantities that are variable, which means not constant, all right? Okay. Human beings make mistakes, and this is what happens here in this lesson. Letters, in this takeaway, letters represent variables which are not constant. If they become constant, there's no need for them to vary. We might do this when we don't know what the value is, or when we want to understand the relationship between values, rather than specific values. So somebody asked yesterday, why do we need all of this? Well, we are trying to model something that is more general when we don't want to know the specific values. We only want to know the model that we can use all the time, right? All right. Let's look at this point here. You have heard phrases like a quantity that varies or a quantity that stays constant in this lesson, right? So numbers basically stay constant, like that 120 that you're adding each time to the vehicle cost. That's a constant. All right. The P, which is a vehicle price, could vary. And obviously the F or the T, which was the final or the total cost, they would also vary according to how P changes. All right. The R, which we use for taxes, could also vary. All right. And so that's the idea here. Okay. Let's see what else we have. All right. This is your cool down, which obviously we're not going to go over. This is for you to do your cool down. A school choir needs to make a school choir needs to make t-shirts for its 75 members and set aside some money in their budget to pay for them. The members of the choir decided to order from a printing company that charges $3 per shirt, plus a $50 fee for each color to be printed on the t-shirts. Write an equation that represents the relationship between the number of t-shirts ordered, the number of colors in the t-shirts, and the total cost of the order. If you use a variable, specify what it represents. In this situation, which quantities do you think can vary? And which quantity can be fixed? So again, what quantities can vary in this scenario here? Look at the costs. And what quantities do you think might be fixed? Again, hint, look at the charges. They're charging $2 per shirt. They're charging $50 fee for each color to be printed. All right. Make up an equation, right, for the total cost. All right. Make up an equation for the total cost. One equation, that's all you're writing, total cost, and ask yourself, for this equation, in this equation, what changes and what stays the same? All right, or what things stay the same? What things are thing or things stay the same, and what thing or things change or changes? All right, so that's your cool down. Okay, I hope this made some sense to you. All right, catch you later.